Alright, we're going to start on the second set of work in your week 3 packets. This is factoring expressions. We haven't done a whole lot of this yet in my class. Now, Mr. Roger's class, you guys did. So we're going to kind of start from the ground and work our way up. I will work all of these problems with you. I'll work 11 of the 12 with you to make sure that we have it right. Alright, factoring expressions. Factoring means pulling out what is in common. This word is pulling out. We're taking out whatever all of these have in common. So, looking at number 1, 8a minus 16. I'm looking for a number or a variable or something that 8a and 16 have in common. Well, because I know my multiplication facts, I know that there's an 8 in common. If I say 8 times 2, I'm going to get 16. And I know that 8 times 1 is going to give me 8. So I'm going to pull the 8 out. And if I divide this by 8, I'm going to be left with A. If I divide this by 8, I'm going to be left with 2, and that's going to be a positive 2. So that's my answer. Now, to check myself, I'm only going to do these in the first couple so that you kind of start getting the rhythm of this. To check myself, if I stake dinner or distribute this, 8 times A gives me 8A. 8 times 2 gives me positive 16. And look what I've got. I've got the exact same thing. So that tells me that my answer is correct. The whole purpose of this is to factor, to pull out what is in common. It's another way to simplify a problem. Alright, we're going to look at number 2. What does a 12x and a negative 20 have in common? Well, if I list my factors of 12, I know I've got 1 and 12. I've got, not a negative 12, it's regular 12. I have a 2 and a 6 and a 3 and a 4. If I list my factors of 20, I have 1, 20, I have a 2 and a 10, I have a 4 and a 5. I want to find the biggest number both of these have in common, and that's going to be the 4. So I'm going to pull a 4 out of both of these. So if I divide this by 4, I divide this by 4. I'm going to say 12 divided by 4, that'll leave me 3x. 20 divided by 4 leaves me 5. That's a negative 20, so my 5 is negative. And just to check myself, just to make sure that I'm right, 4 times 3x gives me 12x. 4 times negative 5 gives me negative 20. This answer and this answer are the same, so I know that I'm right. Alright, kind of starting to see the rhythm here. We're pulling out what is in common. I've got to know my multiplication facts for these. Alright, on number 3, I've got a 6 and an 18. To make a 6, I can say 1 times 6 and 2 times 3. That's it. 18, I can say 1 times 18, 2 times 9, 3 times 6, there's no 4, there's no 5, I've already got 6. Okay, I'm good. So I'm looking for the biggest number in both of these lines that they have in common, and that's a 6. So I'm going to divide both of my numbers by 6. So negative 6a divided by 6 is going to leave me with a Can't forget my negative. So I've got a negative a. 18 divided by 6 leaves me with 3, and both numbers are positive. So to check myself, just to make sure I'm right, I'm going to stake dinner this, I'm going to distribute it. 6 times negative a gives me negative 6a. 6 times 3 gives me positive 18. Look what I've got. Both answers exactly the same, so I know that I'm right. Alright, number 4. I need to know my factors of 14. What makes 14? 1 times 14, 2 times 7, 3 times, no, 4 times, no, 5 times, no, 6 times, nope, and I've already got a 7. So these are all of my factors for 14. 21. 1 times 21, 2, no, oh, 3 times 7. There is no 4, 5, or 6 because I know my multiplication tables. I'm looking for the largest number these two have in common, and that is a 7. So I'm going to divide these by 7. Kind of got a little squished up there. 14 divided by 7 is going to leave me with negative 2w minus 3. But there's something else I can do here. You see how both of these are negative? I can actually pull out a negative and add to that 7, and that would leave me with 2w plus 3. This answer is more right because the more factors are pulled out. So this is the answer that I prefer. This one's not wrong necessarily, but this one is better. Alright, you can go back and check it. You can stake dinner this and make sure that you're right. I'm not going to spend the time doing that because this video is going to get really long. Alright, now we noticed something a little bit different on number 5. I noticed that I've got an A family, I've got a B family, and I've got a plain Jane family. I haven't dealt with any of those yet. Can I put any of those together? A family, B family, plain Jane family. No, I can't. I can't put any of them together. They're all different families. But I still need to know the factors. I still need to pull something out. So for 8, what are my factors? 1 times 8 and 2 times 4. That's it. For 12, 1 times 12, 2 times 6, and 3 times 4. For 28, 1, 28, 2, 14, there's no 3, but there's 4 and 7, there's no 5, and 6, is there a 6? No, there's no 6. Alright, so the largest number that all of them have in common, and what I see is a 4. They've all got a 4 in common. So I'm going to pull a 4 out. 8 divided by 4 is going to leave me with 2a. Can't forget its last name. Negative 12 divided by 4 is going to leave me negative 3b. 28 divided by 4 is going to leave me with positive 7. So if I wanted to, I could go back and distribute, multiply all of that out, and I'll get the exact same answer. Number 6. Again, I notice I have an X family, a Y family, and a plain Jane family. Can I combine those? No, I cannot, because they're all different families. I need to know my factors of 6. I've got 1 and 6, 2 and 3. My factors of 15. 1, 15, 3, and 5. For 24, 1, 24, 2, 12, 3, 8, 4, and 6. Kind of got a little scrunch there. Alright, what is the largest number that they all have in common? And I see the largest number they all have in common are 3s. So I'm going to pull a 3 out. Negative 6 divided by 3 leaves me a negative 2x. Can't forget its last name. 15y divided by 3 gives me positive 5y. Negative 24 divided by 3 gives me negative 8. And if I wanted to, I could go back and multiply these out, distribute, use steak dinner, and I would get exactly the same answer, and I would know that I'm right. Guys, I know these are a little more complicated. I know. Just hang on with me. I got you. Alright, number 7. Number 7, I've got A family, plain Jane family, A family. Oh, what do I have here? A family, plain Jane family, A family. I need to put my A family together. So 2A plus 7A is going to give me 9A. Is there anything I can combine with plain Jane? Nope. So now, this is the problem that I'm going to work off of. I need to know my factors for 9. 1, 9, and 3. And my factors for 3, 1 and 3. The largest number they have in common are 3s. So I'm going to pull a 3 out. 3 divided by 9a leaves me a 3a. 3 divided by 3 gives me a 1. And again, I could distribute, multiply, steak dinner that out, and I will get the same answer. Number 8. I've got X family, plain Jane family. I need to put my X family together. Negative 2 minus 8. And in my calculator, I'm going to get negative 10, but I can't forget my X. And I've got plain Jane. There's nothing to combine plain Jane with. So now, this is what I'm working on. I need my factors of 10. 1, 10, 2, and 5. I also need my factors of 20. 1, 20, 2, 10, 4, 5. What numbers do they have in common? What is the largest number they have in common? On this one, I see 10. I'm going to pull a 10 out. 10 divided by negative 10x leaves me with a negative x. 20 divided by 10 leaves me with a positive 2. I'm okay with this answer. I like this answer because it's easy. But I want to show you something else. I want to show you what some people would consider to be a more right answer, but they're equivalent. What does equivalent mean? They're the same. So, a lot of people don't like to have this negative variable right here. So to make this variable positive, I know there's an invisible 1 right here. How do I get rid of a negative? We're going to divide. So if I'm going to divide this by a negative 1, I'm going to divide everything by a negative 1. Whoops, negative 1. So that's going to make this 10 negative. That's going to make my x positive and make my 2 negative. So whether you give me this answer or this answer, I'm okay with it. As long as you know these are equivalent. And you can go back and steak dinner this. You can go back and distribute and multiply it, and you're going to get the same answer either way. Just know that a lot of people don't like to leave variables negative. It makes my brain itch, but it's okay. Alright, next one, we have Y family, plain Jane family, Y family. What do I need to do? I need to combine my like terms. I need to put my families together. So I'm going to put my Y family together. 5 minus 25 gives me negative 20y. I have nothing to combine the 10 with. So this is my brand new problem. I need to pull my factors out of here. I need to know my factors for 20. 20 is 1, 20, 2, 10, 4, 5. For 10, I have 1, 10, 2, and 5. What is the largest number you see? I see 10. So I'm going to pull a 10 out. Negative 20y divided by 10 is going to leave me with negative 2, can't forget my y. 10 divided by 10 is going to leave me with a 1. This is the same case. A lot of people, it makes their brain itch to leave this negative. So if I say negative 10 positive 2y minus 1, I'm going to get the same answer. Just so you know, either one of these I'm okay with, even though it makes my brain itch. Alright. Number 10. Number 10 looks scary. It looks really scary, but it's not. I promise. We've got this. We've got this. So, first thing I want to do, I want to go through and find my families. I've got X families. And I've got plain Jane families. But before I can put my families together, I've got this right here. Now, I know there's an invisible 1 right here. And I know this whole thing right here travels together because of these parentheses. These parentheses tell me that this negative 1 is smushed against the parentheses. What does it mean when something is smushed? Multiply. So I have to multiply everything in these parentheses by a negative 1. Negative 1 times negative 3 gives me positive 3x. Negative 1 times negative 9 gives me positive 9. I'm done with that. I haven't touched anything else yet. So I'm just going to bring it down. This 3 is positive. Now, here's my new problem. I've got X family, X family, X family, plain Jane family, plain Jane family, plain Jane family. Now I need to put my families together. 4 plus 3 gives me 7. 7 plus 9 gives me 16. I can't forget my family name. 7 plus 9 minus 28 gives me 12. Now, what is it I always say? What is the question asking? What is the question asking? This question is asking, rewrite the factored form if it's possible. Rewrite in the factored form. So that means I need to find out what they have in common. So, for 16, to make 16, I can multiply 1 and 16, 2 and 8, and 4. 4 times 4. For 12, I can say 1, 12, 2, 6, 3, and 4. What is the largest number they have in common? I see a 4. So I'm going to pull a 4 out. 4 divided by 16x gives me 4x. I'm sorry, 16x divided by 4. Negative 12x divided by 4 gives me a 3. Let me rewrite it this way so you can see it. And now we're done. If I were to distribute, I would get that same answer. Alright, let's look at the top one on your last page. What is the question asking? Determine which of the following expressions are equivalent. Equivalent. What does that sound like? Equivalent, in my brain, sounds like equal. So the question is asking me, which one of these are equal? I'm going to use my handy dandy calculator on this one because I see a bunch of fractions. I'm going to make life easy on myself and I'm going to change the fractions into decimals. So my first fraction, 1 over 6, I'm going to say 1 divided by 6. That gives me 0.16 forever and ever. And that's going to be times negative 3. Just rewrote it, changed my fraction into a decimal. So now I'm going to distribute. 0.16 repeating times x gives me 0.16 repeating x. 0.16, fill up my screen, times negative 3 gives me 0.5. I'm going to go ahead and round that one. Alright. I'm going to bring this one down, write it in blue. 1 divided by 4 gives me 0.25x. I'm going to change this one into a decimal as well. 3 divided by 5 gives me 0.6. Change this one. 1 divided by 12 gives me 0.083 repeating. And I can't forget my x. I change this last one. 1 divided by 10 gives me 0.1. Now, I've got X family, X family, plain Jane family, plain Jane family. I need to put my x's together. So I'm going to say 0.25 minus 0.083 forever. And that gives me 0.16 repeating forever and ever x. Now I need to put my plain Jane family together. 0.6 negative plus 0.1. Hey, look at that. Look what we've got. They're the same. Interesting. Well, let's go on down to the next one. I want to change this into a decimal as well. So I'm going to say 1 divided by 18. That gives me 0.05 repeating. Can't forget my x. I want to change this to a decimal. 1 divided by 9. That gives me 0.1 repeating. Can't forget my x. You should know this one. 1 divided by 2 is what? 0.5. So what do I have? I have X family, plain Jane family. So I want to put my X family together. And I want to say 0.05 forever plus 0.1 forever. Look at that. 0.16 forever and ever and ever x. Is there anything I can do with that? Nope. So look at what I've got. All three of these are exactly the same, right? So what does that make all three of them? It makes them equivalent. All three of these are equivalent. So I want to challenge you to something. Look at number 12. Number 12 says, explain a different method you could use to solve problem 11. What's another way we could have done that? We changed everything to decimals. We could have left it as a fraction. Could we have used factoring? Maybe. What other ways can you think of that we could have solved number 11? I want you to do that. I want you to think about number 12 and see what you can come up with. Look, guys, I know this one was hard. I know this is something we didn't spend a whole lot of time on. Please let me know if you need help. If you have problems with specific ones, if you have questions on how I got certain answers, send me a message in Google Classroom and I'll get back to you. I love you guys. See you soon.